when we have a function with f of x plus delta x, that is the same as having approximately f of x plus f prime of x times delta x. And so, for example, to say the values here, delta x is equal to the difference in x. So I guess say x2 minus x1. And so an example of what I'm saying is, if your f of x is square root, for example, I don't know, 4.5, then what you would do, your delta x in this situation would be square root of x. An example of this problem will be if f of x was the cubic root of 25.5. Here we know that the cubic root of 27 is equal to 3, so that is a much easier number. So the number that we choose is 27, and the number we are given is 25.5. So our delta x would be equal to 1.5, I guess negative. So then we get the equation, which is f of x is equal to the cubic root of x. The derivative of this, which f prime, would be equal to 1 over 3 the cubic root of x squared. So then all we need to do is plug in our chosen value into these and multiply it times the delta x. So then what we do is the cubic root of 27 plus 1 over 3 times the cubic root of 27 squared, and all this multiplied times negative 1.5. And so the final answer we get from this is 22.9444, and then this number repeats. And if you actually were to plug in this original equation into the calculator, you get that the value is actually 22.933 something. Right? So the approximation is actually sort of accurate.
Hi, hello, my name is Jose, and today I'm going to explain how to approximate using differentials. So this is our first example, radical 16.5, and the first thing we need to do is to find f of x, which is square root of x, and then we need to find the derivative of this, of radical x, and the f prime of radical x is equal to 1 half square root of x dx. So now what we have to do is, this is our differential, so we have to do is the square root of 16 plus, we substitute the 16 here, so it will be 1 over 2 times the square root of 16, and the dx is 1 half, so this is 1/8 times 1 half, and this is 4, so we have 4 plus 1 over 16, and if you actually do this on a calculator, this and this are pretty close together.
Okay, so this is our second problem of approximate using differentials. So the first thing we have to do is to find out the function, and we can notice here that we can interpret this as an x. So the function is 1 over x to the 6th power. Then we have to find the derivative of the function, which is f prime of x, that is equal to negative 6 over x to the 7th. So now that we have this, we have to find out the approximate value of our number, which is this of our x. So the x is 1.003, which is a number that's really close to 1. So we can interpret this to get the approximate value by doing the problem with x equal to 1. And to find out the difference of the given value and the approximate, we do delta x, which is 1.003 minus 1, and we get 0.003.
So you already have the delta x that is 0.003, and then to get the answer you gotta plug this original equation but with the approximate x. So you have 1 over 1 to the 6th power plus the prime equation, that's -6 with the approximate x, that's 1 to the 7th power. All this multiplied by the delta x, 0.003. So then you do all these equations in the calculator and you get 0.982, and that's the exact same answer as the original equation.
The pros of using this method is that you are able to approximate a value that would be usually difficult to get without using a calculator. I mean, you wouldn't be able to do it using mental math, and if you don't have a calculator, this is the best way to get an approximate number. The problem is, or the con is, that it won't be the exact number. It'll be approximate. It won't be exact, but it'll be pretty close.